Great, here we go. We've got a problem here called replaceAll, taking in three arguments: input, find, and replace. Isn't it annoying how string.replace, taking in find and replace, only replaces the first match of the find string? Write a function, replaceAll, input, find, replace, that will replace all matches of the given find string with the given replace string. The function will always be called with three strings, so don't worry about validating the arguments. As with the original string.replace, if find is an empty string, it should match in between each character, effectively inserting replace in between each character, including the start and end of the string. I've given you some tests for this to make it a little clearer. All right, before we get into this problem, I'm going to jump over to Replit and I'm going to try/demonstrate a couple things. Depending on the familiarity you have, you may or may not be familiar with this. So let's make a string. We'll do let string equals, I don't know, school bus. And then we'll do string dot replace. And the first thing we're going to do is say what we want to replace. Let's say SC, and let's say we want to replace that with ZZ. So let's go ahead and run that. And we see that it's taken out the SC and replaced it with ZZ. Easy enough. But what if we want to replace all of the S's? So I do string dot replace S with Z. And I'm going to go ahead and run that. All right, so it's replaced the first S, but not the last S. So this is somewhat the crux of this problem. Replace only replaces the first time that it actually sees something to replace. Now, it also talks about if we do string.replace, passing in an empty string and replacing it with Z. Interesting. I'm not sure why. It seems to imply that if you do this, that it will put Z between every character. We see that that's not what happens here, but that's what it wants us to do in this function. So when we pass in an empty string like this, the result in our problem should be something like Z, S, Z, C, Z, H, Z, O, etc. So it's school bus with Z's between every letter, including before and after it. And I just want to demonstrate that is what replace does, and that's how it works. Let's go back to the problem and see what we can do. So they want us to do something like that, except for in the case of, for example, school bus, we would replace both S's with Z's. And we've got some tests down here. This first one, for example, string replacing the ing with an exclamation mark. So we would replace this with an exclamation mark. We would replace this ing with an exclamation mark, and we end up with this string here, which we can see that matches that. Got to be careful to, of course, uncomment that because we don't want that to mess up our test. All right, how can we do this? So one way we can do this, and probably I think the most intuitive way, similar to what you've done many times before, is imagine if I have a string like this, and I start a for loop where I point at the first element in the string, the first letter, and then I look at the length of my find. In this case, it's 3, and I say, okay, look between 1 and 0, 1, and 2. So this was pointing to the R, and compare that to the find. If it's the same, then go ahead and replace those 3. Otherwise, move on to the next one. So I move up 1, and I move this up 1, and I look at TRI. Does TRI match ing? No, it doesn't. So we move up again. This is pointing at R. This is pointing at N. Does RIN match ing? No, of course it does not. So I move up again, and now we see our first match. I'm seeing ing here between my 2 pointers, and I'm seeing ing in find. All right, so I want to take that away and make it an exclamation mark while then moving up my pointer. Now the problem is that because we're not going to mutate this string, we're actually going to start a new string. So if I had let my string equals something like this, Then following that same logic, we go back to here and we say, does str match ing? No, it doesn't. So we'll go ahead and add just the s onto this string. And then we'll do that for tri, and it doesn't match. So we'll add the t, and then we'll move on to rin, and that doesn't match. So we'll add the, r. And then again, we get to this ing. Okay, ing does match. So we'll add our replace value here, which is an exclamation mark. And then if we're doing a for loop where we're moving up one at a time, in this case, we need to move up by the length of find minus 1. So I'm automatically going to move up 2 at that point. And then when my loop starts again, I'm going to be pointing here. So I say, does the dash st match? No, it doesn't. So we're going to add a dash, and so on and so forth until we get to the end. We'll follow this logic now to see how that's going to work. So first thing we want to do, set up an empty string. And the last thing we're going to do is return string. So I'll just go ahead and do that right now. Then I want loop through each character of input. And we want to have, inside the loop, we want to have access to the length of find later. So we'll just do a regular for loop so that we have access to I. Here we want to say, does input from I to I plus find dot length equal find? If it does, string add replace to string, as well as increment I by find dot length minus 1. If that second part is not clear, we'll go over it when we write out the code. If not, add char at I. Okay, I think that's all the code we need. So let's see if we can write this up. So here's my loop. For let I equals 0. Okay, typo. I equals 0. I is less than input dot length. I plus plus. And this is all going to be inside of our loop. Okay, if input, now how do we get from I to I plus find length? We can use slice. That will give us a slice of the string from I to I plus find dot length. If that equals find, again, this is all going to go in here. I'm going to ignore this for now. I'm just going to move on with this here. Add replace to string. So string plus equals replace. And then increment I plus equals find dot length minus 1. Okay, great. Now, if not, otherwise known as else, I'll just put that right there. This becomes our instructions in here. Clean up just a bit. Add char at I. So in case this isn't clear, we want to do this to string. So string plus equals input at I. That will give us the character at I. At I. All right. So again, I'm just going to clean up a little more. Don't like messy code. Okay, looks good, looks good. Return our string. All right. Now, let's try this on this first test here. And as you many times see me do, I'm just going to comment out the rest of these tests. Let's see if we're passing. Yep, looks like we're passing this string. If you want to, I don't know, give yourself a little sanity check, we could do console.log string just to see what we're getting here. It doesn't pass. I guess it doesn't print it out when we, there it is. We just have to open down the little test there and we'll see it. So we see that we're doing it correctly. Now let's review one piece of the logic here. In the case that we slice out our length of 3, right, and we add that to our string, what we're doing is we're saying when we're pointing at I and then we slice out ing, we don't want our pointer to then go to ng dash and look at that because we've already replaced all of ing. So normally our pointer would move forward 1, but we want it to move forward 3. And because we're always moving forward 1, I'm taking find by length, which is 3, minus 1, which is 2. So we're moving I forward 2 places, and then when the loop starts again, that's going to move it forward 1 more. And that is dynamic so that if find is longer, then it's just going to skip further ahead in that. All right, so that is sort of the common case with this problem. Now let's look at these edge cases that they're explaining. So given an empty string and an empty string to replace from, this is saying it should put the, or an empty, given an empty string and the find value is an empty string, it should give us the replace value. So we can at least experiment with just writing out conditions for these, since these are pretty narrow cases. So if I say, if there's no input and there's no find, return replace. Let's try that. Okay, that passes that case right there. Pretty easy to see why that works, right? There's no input. An empty string is a falsy value. So if input is false, meaning it's an empty string, and find is false, meaning it's an empty string, then just return whatever is in the replace thing, the replace argument. All right, now here we've got a 1 finding nothing, and we're returning this replace character. So let's try that. Did I click on attempt? I didn't mean to. That was a mistake on my part. Now it's gonna, yep, okay. Let's go back to test. Oh, it's, so I did click on test and I just made my loop timeout here, I think. Okay, so let's think about the logic here. If there's no find value, return, we want to return the, you know what? Let's just follow nice test-driven development. We'll do return find, I'm sorry, replace. We see that it has the replace value plus the input value plus the replace value. And let's test that. Okay, great. We've solved that case there. Now we've only got this one last case here. So it's still, there's still no find, but we see that whereas ours is going to give us dash 1, 2, 3 dash, we need to interpose a dash between all of the numbers. So we're going to work on this right here. I'm just going to do input dot split on every character, and then I'm going to join them on the replace value. And I'm going to leave the replace at the beginning and at the end. And let's go ahead and run that. Lovely. And finally, let's go ahead and attempt the problem. Okay, that's all there is to it. That'll solve this problem. Now, we didn't really get into how you could do another type of solution, which would look like, I'm not going to demonstrate this whole solution, but I will show briefly. If we did something like this, we could do return input dot replace, back to this replace, passing in a regular expression with the G option here. And if you don't know what regular expressions are, we will learn more about that another time. And then we want to do our replace here. And then in here we can put find. So let me comment this out. Now this will not be a fully working solution, but what this should do is say, okay, oh, you know what? I think even this, I need to do find equals a new regular expression passing in find, comma, G. This syntax is not on the tip of my tongue. And then here we can do find. Let's try that. Okay, so you see this passes all of these as well with much less code. So that's great. However, when I go to attempt, it does not pass. And that is because regular expressions have certain special characters that we need to write a longer solution for to get this. So I'll leave that for you. If you want to dive into how to write this with a regular expression, you certainly can get into that. But for now, just know that you could do nothing other than just write a very iterative solution, going over the problem, looking for any patterns that match, replacing them. And I think the only real gotcha here is making sure you've got these conditions set up top, and then making sure that you jump I by the length of find -1 every time you find a match. That's all there is to it. Again, we'll do that and submit it, and we're done. Thank you.